And finally, one more idea with angles that's a useful understanding for us to comprehend is this idea of complementary angles and supplementary angles. Complementary angles means I have two angles that add up to 90 degrees. So here I have two angles and they add up to 90 degrees. These are called complementary angles. Supplementary angles then are two angles that add up to 180 degrees. And 180 degrees is a straight line, so if I have any other angle, maybe inside, so there's two angles, those two angles add up to 180 degrees, therefore I would call those supplementary angles. Now, how would I describe these angles in relationship to each other? Let me give you an example. If one angle, well, like I said, I don't know either angle, so I'm going to call one angle an x. So what would you think we would describe the other angle? We don't want to use y, we want to maintain just one variable being x. So if I know that both angles together equal 90 and one of them equals x, the other one's going to be what's left over, or 90 minus x. So complementary angles then would be x and 90 minus x. Similarly, supplementary angles would be, if I described one in terms of x, the other one's going to be 180 minus x. And we would call those supplementary angles. So let's use this information to solve a word problem. So here's my tricky word problem. I have an angle whose measurement is 40 degrees less than that of 4 times of its complement. So I need to understand I'm working with complementary angles. So one angle, in this case the angle I don't know, is the measurement of the angle. And then this complement, how would I write that? Is going to be 90 minus x. That's the complementary angle. So how can I use that information to figure out what's going on? So I have some angle, which we don't know, which is our variable. I know it's 40 degrees less than, so I'm going to take away 40 from something, less than what? 4 times the complement. And the complement again was 90 minus x. I know that looked easy, and it becomes easier with practice, but you have to practice working with these types of things. So does this equation make sense with our word statement? Is some angle, is it 40 less than 4 times its complement? That's what the words say, and this is the algebraic way to state that. So from here then, what's that angle? Or what are the two angles? Well, we can solve for x. 4 times 90 is 360, minus 4x, minus 40. Collect some like terms, 360 minus 40 is 320. Add 4x to both sides. So I get a 5x equals a 320. Divide both sides by 5. 300 divided by 5 is 64. So what are the two angles in my particular situation to make this true? Well, x is 40. So if I had complementary angles, whoops, one is 64 degrees. The other one's going to be 90 minus 64 degrees, which is this complementary angle, which gives me what, 26? 26 degrees. And then 64 plus 26 add up to 90 degrees, which are my complementary angles. Now, of course, as a side note, complementary angles don't have to be connected to each other. I could have one angle over here, which is 64, and another angle over there, which is 26. I can still call those two angles complementary because the sum of their angles equals 90. So I don't have to connect them this way that I've showed you in my illustration. Hope that's helpful. Again, practice, practice, practice is going to help this stuff make a lot more sense, and then it will become enjoyable and fun if it isn't already.